My name is Dan Lydey with Lydey Automation. Thank you for joining us on this streaming live Zoom call presentation of the Intelligent Actuator EleCylinder. Just back up here a second. We're doing these because with COVID right now, it's a little challenging for us to get out and about to all of our customers. A couple of things that you ought to know. Lydey Automation is open. All of our manufacturers are open and shipping product. We're making sales calls and service calls at this time. We have been all along. We're following all the protocols from social distancing and masking. If you are open and accepting sales calls or do need service, please don't hesitate to call our salespeople. We will accommodate any requirements that you do have. So with that, we have begun doing some Zoom live streaming calls to show off some of the newer products to keep you still informed on things that are going on with our manufacturers. So today we're going to be highlighting the Intelligent Actuator EleCylinder. A couple of tips real quick before we get any further. We're using Zoom. Everybody uses either Zoom or Teams or Skype. A couple of tips. If you go up to the top right, there's a gallery view or a speaker view. You want to click on the speaker view. That should highlight this. And then you also should go into full screen. We're going to be using the camera here to show everything on here. And then I'm also going to be sharing my screen and downsizing the camera and showing some of the software. As you can kind of see off to the side here, we'll be showing some of the software and how to set this guy up, and maybe even a couple of PDFs just to demonstrate and show off some more of the product. But Intelligent Actuator, let's start on that. Intelligent Actuator is a manufacturer we've been with for about 18 years. Intelligent Actuator is known for their electrical, linear, and rotary actuators. That comes in many different forms, from the SCARA to the multi-axis Cartesians, but more specifically, most popular is the RoboCylinder. The RoboCylinder is a very broad product line, including linear actuators, rotary actuators, electric grippers, and it is has a lot of capacity to it. We can do multi-point, we can do coordinated moves with a couple of different access, we can do field bus communication. There's a lot of things that we can do in the RoboCylinder product offering. It's been our most successful portion of the Intelligent Actuator. But now with the EleCylinder, we are coming out with a new product that's very diverse and very broad, but is specifically geared to go at that of the pneumatic applications. You're going to see here, let me open up a little PDF that I have to illustrate this. We have a very broad product offering on the EleCylinder. We have the slider style, we have the rod style, we have the table mini type, and then of course we have a rotary actuator, and then we also have a stopper cylinder. You'll notice here on the table, the demo that I'm going to be working with is the slider style. Here's a couple of your stopper cylinders. Here's a table style with the rails, and then here's a larger slider style. We also have the radials, or I'm sorry, the rod style, which isn't represented here on the table. But one of the nice things about the EleCylinder is that all the cylinders have a guided mechanism that, let me scroll down here. In our slider styles, this represents it nicely, this cutaway here. You can see that they're mainly ball screw. We do have some belt drives, but mainly ball screws that have a carriage that is riding on ball bearings, linear ball bearings. This allows us not only in the slider style, but also in the rod style to handle a side load or a radial load to the actuator. The actuators will come complete with the motor, the coupler, the ball screw, the slider. Everything is included, the controller, everything is included in the EleCylinder, even the cables. So let's show you a little bit about the actuator here and explain a little bit about it. This demo here has, of course, the slider, the cable that comes with it. This incorporates the controller. And then what I have over here is a 24-volt power supply. These are all 24-volt devices. And then this is basically mimicking the output of our PLCs. If I select one of the buttons, it'll retract it. If I select the other button, it'll extend it. So the simplicity of the EleCylinder is that, again, we're going after the pneumatic applications. Most pneumatic applications are extend to the end of stroke and retract back. So it's a two-position device, okay? Usually, if we ever get into a third position, it's during an E-stop. So we would be retracting, and we would hit an E-stop, and we would dump our solenoids. The nice thing about the EleCylinder is when we dump our solenoids, we lock that guy in with 100% torque and stop that cylinder. If you compare and contrast that to a pneumatic application, there are several different ways to do it in a pneumatic application. We could have a three-position valve with a closed center to it, and we're trying to trap the air. In that application, if you had some external force, it might move back and forth, or if you had any leaking, you could have the cylinder move back and forth. You could have a three-position exhaust center. That would exhaust all the air to the system, and now the cylinder would be able to move with any external forces or gravity working on it. You could use dual pressure supplies. You could use pilot operated checks. You could use a rod lock. There's a number of different ways that we can handle a E-stop in a pneumatic application. The reason there are so many different versions of that stopping of a cylinder in an E-stop on the pneumatic side of the world is that none of them work for all applications, and quite honestly, in a lot of applications, it's a little challenging to get it to do exactly what you want. The nice thing with our EleCylinder is we are riding it back and forth with two solenoids, just like we do on a double solenoid valve. But when we hit an E-stop, we stop dead. We have the motor driving it and holding it in position in that E-stop condition. When we want to come back on it, we simply drive the solenoid back. If we have a restart command, we can even do a absolute encoder on the EleCylinder to know exactly where we're at all times. So if you shut down the machine and move it around, we would know and be able to come right back and pick up our process right where we left off. So let's discuss a little bit about all the different things, because this gets into kind of the price point of the EleCylinder. The EleCylinder is intended to replace pneumatic applications. So we would have, of course, a cylinder on there. And then on either side of the cylinder, we would have a couple of flow controls. We would have tubing running back to a control valve. We would have, of course, the control valve, potentially a pressure regulator on the control valve. And then we would always want a couple of switches on the cylinder to know exactly where we're at. The nice thing with the EleCylinder is we're running either an incremental or an absolute encoder here, which is giving us a signal back to the PLC when we hit our end of stroke. So while I have these two outputs running it back and forth, I also have, when I get to this location, an input to my PLC telling me that I've made this position. The interesting thing, Intelligent Actuator has done studies, and according to Intelligent Actuator, the single largest cause of downtime on a factory floor is due to cylinder switches. We've all learned to live with them, but they are a problem child in the fact that they're hanging out to the side, their potential to damage, and their potential to failure. With this, we've eliminated them on it, and it's actually coming from the encoder and doing a real nice job. With that said, let's go into, I'm going to shrink my screen here a little bit and show you what my setup is on my EleCylinder. We have many different ways to set up the EleCylinder. We're going to touch on the one that uses the RoboCylinder software. This is the exact same software that we've been using on the RoboCylinder for years, whether it's the rotaries, the linears, it's the exact same software. IAI is not in the business of selling software. Once you purchase the software for one application, you get it for life. So it's and again, it uses it across their realm. So here you have your software, and I'm going to pull up our position data. If you're familiar with the RoboCylinder, you're going to look at this screen and say, geez, this is a little bit different. It is the same software, but when it's plugged into an EleCylinder, it's pulling up a little bit different application. And the fact, what we're seeing here is right here, I have my extend stroke. And this is done in, I have three variables here. I have my acceleration, I have my velocity, and I have my deceleration. With the acceleration in percentages, I have 100%, 36% of the velocity, and 100%. To change those units, if you wanted to work in different units, I click the unit change, and that takes me into G's, millimeters per second, and deceleration. Now here we can modify these, and I'm going to come back to that. Over here we have our extend or our retract side. Exact same layout, but working on the retract stroke. Down here, we have our position setting. This is really interesting. When you order a 12-inch stroke cylinder, unless you put a pneumatic cylinder, let's say, unless you put an external stop, you're going to have 12 inches of stroke. On our EleCylinder, you can come in here and change this at the setup point and modify it. This guy is a 150 millimeter stroke, and I'm going to change it to be home is at 10 millimeters and extend is at 140 millimeters. Once we set that up, we click our transfer button. Oops, I have to go into teach mode so I can modify this. Once I hit my transfer button, we transfer that up. And now I'm going between 10 and 140. If I want to change my speeds, I can come up here and enter a slower acceleration and slow this guy down to 25 millimeters a second. And we'll slow down my decel. And now I hit a transfer button. We put that up into the controller. And now, whoops, you can see that my stroke is going very slow on the extend. And I still have my fast speed on the retract. If I let go of that button, just like if I dump my outputs on my solenoid for a pneumatic application, I'm going to stop right in mid-stroke. As you can see, we're holding full torque. I come back on that, and I continue on. So you can see here that this is very simple in your layout. You're reading your position down here. You've got your buttons that are mimicking your solenoids, so you can test this out and make all the modifications you want. Now, you can see that the software is very easy, and I mentioned we're just going to touch on them here very briefly, but there are a couple of other ways that you can program or set up, if you will, because that's certainly not programming. This unit has actually a digital screen on it that allows you to adjust your locations, your speeds, your accelerations, all the things that I just adjusted on the software, we can do it on this screen. We can also outfit these to have Bluetooth and have an actual pendant that is set up very comparable to the software. And with that pendant, you can now go out and attach to it Bluetooth to multiple units on a machine and set up and change and modify the speed, the acceleration, and the stroke amount on each one by identifying which one on the Bluetooth pendant. So basically what we've been able to show you here is a very broad line of linear actuators and rotary actuators that again are going after and mimicking that of a pneumatic application. We're doing it and allowing you to adjust your speeds, your accelerations, your strokes, and doing it in a very precise way with the electric actuators. Just to give you a ballpark figure on your basic actuator, you can assume that you're going to be in about the $900 to $1,000 range on your actuator, and that includes the actuator, your controller, and all your cables. That's a very broad number, but when you compare and contrast that with the air cylinder, fittings, flow controls, tubing, cylinder, switches, your solenoid valve, and pressure regulator, we are right in that ballpark of a pneumatic application, giving you the precision of the e-stop, the control, acceleration, all the other things. So that is the EleCylinder. It's not the EleCylinder in its entirety. We did show you the teach pendant, and we didn't show you a couple of other things, but it gives you a very good view and understanding of the EleCylinder. At this point, we're going to open it up to questions. We're going to open up the chat function. And I'm going to stop sharing my screen here. And if we can go into, if anybody has any questions on the chat, we should be able to see them here. How well would this work in a welding application? I got to be honest, I don't have a perfect answer for you. We have it deployed the robo-cylinders in weld applications. We have done it successfully. I would want to double check the application, see where we're at in the whole weld field scheme of things. But Nathan, I appreciate your question, and we will certainly follow up with you on that for a better explanation. Do we have any other questions? We got another question here as to the extent of the stroke limitations. Depending on the unit that we have, we can go up on the belt drives up to 2.5 meters. So you're getting out there 8 feet in stroke on the belt drive. On the ball screw, we are limited a little bit more, and that depends on your size and your version. Usually we're staying under 1 meter on the ball screw versions. Any other questions? Okay. Doesn't appear as though we have any questions. We're gonna be putting a tape version of this out on YouTube. If anybody, we wanted to start on time. I went 20 minutes today, a little bit over. We got into some questions, or oh, here's a good one. The estimated positioning accuracy. These are going to be very comparable to that of the robo-cylinder. In the robo-cylinder, our accuracy or repeatability of the position is 0.02 millimeters. So they are extremely accurate. Again, as I mentioned, we can do it with incremental and batteryless absolute encoders, which helps out quite a bit on the restart. Should you have an e-stop or any kind of maneuvering, we come back to life very quickly. But the accuracy, the estimated positioning accuracy, is the number on that is 0.02 millimeters. Okay. For anybody who did start a little bit late, again, we're going to have this on YouTube, and we can send you a link to that. Just please contact your salesperson, and they can direct a link straight to you. Nathan, we'll get back to you on that welding application specifically. But thank you very much for joining us, and we appreciate your attendance.